everyone, and welcome to Week 5 Database Vocabulary. This week we are going to be talking about some database terms such as rows, columns, relations, and keys. We're going to be talking about the process of normalization. We are going to be talking about the advantages and disadvantages of normalizing a database, and we're going to talk about the difference between primary keys and foreign keys. So we're going to start with what is normalization. Normalization is ensuring that the data that we have in our database is being formatted the same way and organizing the data. We are paying attention to functionality, not the attractiveness of the data. We are also looking at the process of creating the relationships between tables. One of the things that will likely happen as you are normalizing your data is you are going to be breaking your database up into multiple tables. Now, I don't mean breaking up, I guess I mean splitting out some of the data to ensure that the format is done correctly. Normalization can also be in reference to normal forms, and that's going to indicate how well the database has been normalized. However, I would like to make a note here. If you are working with databases in industry, you are unlikely to see much about normal forms specifically. They may not use that vocabulary, and if they do, they are unlikely to take you beyond 3NF. That's mostly where a lot of industry places will stop. However, if you're going to be doing this in academia at all, you will hear about it a lot more. Normalization is important so that we can be more efficient of our database. It can make our queries more efficient. It can make it easier to reduce duplicate or incorrectly entered information. Technically, it makes the database smaller because data is only in one piece. However, you have to have a relatively large database to be able to see the gains for this. If your database is small enough, it's possible normalization will actually make your database larger and less efficient because you'll have more table joins depending on how you go about this. Normalization will also allow you to make sure that your data is being updated properly everywhere it needs to be. Some examples of normalization. I would actually recommend the Wikipedia article here. I think that the writers did a really good job, including the table that was created. To get to 1NF, you have to have a single value per field. So when we talk about data and databases, we'll have records, which is the piece of information about the single object. So if we have, for example, a library book, that library book is likely to have title, author, publication date, for example. If your library book has two authors, you wouldn't have both in the author column, so you would have a second author column, or a way of being able to indicate that two authors are there without having both listed in the author field. So 1NF will allow you to have a single value per field. All of the different normalization forms actually require that you have finished the previous normalization. So to get to 2NF, you have to have finished 1NF and remove duplicate data and set up a candidate key. So if we have our library book example and we included the location of the book, let's say we had it at a library in a specific town, we could split out the location key to another table to ensure that it's consistent. So let's take a more specific example here because I think that would be helpful. So let's say, for example, we have authors. So we have our book, which is going to have a title, an author, and a publication date. When we look at book authors, you can see from my example that there are a lot of different ways we could write a book author. It's still the same author, but according to the computer or the database, these would actually be all different authors. So if you have, my example author here is J.R.R. Tolkien. If you have it first name, last name, last name, first name, those are two different authors according to the database. If you have periods between the JRR, or if you don't, that would make it different. If you have spaces, that would make it different. So all five of these would actually be recognized as different authors. If we ended up having pen names or multiple authors, those would also be in here. And if we were normalizing our data, what we would be able to do is have a table that is just authors. We could decide the format that we want our data to be in. Let's say we want the format to be J period, R period, R period, space, Tolkien. We've decided that's how we're going to write this. Then we would be able to say, okay, in our authors table, author 1 is J.R.R. Tolkien. And then every time that is showing up in our books table, we would just be able to say, author ID 1. And then if we needed to update it because we've decided we actually want it to be Tolkien, J.R.R., I would only have to update it in a single place in our authors database instead of needing to go and find every book that J.R.R. Tolkien has written. Now, some things to think about. How else could we split data about books out to be normalized? What are other examples of things that you may want to split out into other tables to ensure that the data is going to be done in a way that will make sense and make sure that it's not duplicated? So what else besides author do you think could get split out? I also have a graphical example here. So my raw data, which apparently has decided to not show up. So the raw data was actually supposed to look like this normalized data here. And instead of having the author IDs listed as 1 and 2, it was supposed to have the author IDs listed here. And the genres were actually listed out. I will try to have that fixed before this is uploaded. Okay, primary keys. Primary keys are an identifier of the different pieces of data that we have. Generally, it's a primary key for the record. They used to be numeric only, so they used to be only numbers. Primary keys must be unique. It is not recommended to use data. So for example, a social security number would be a very poor primary key. However, as a note here, people do still do this. So people will still use data like social security numbers as primary keys. I don't recommend it. I don't think you should do it, but it does happen. You may also see primary keys referred to as ID. That's kind of a Microsoft thing. The modern trend for a primary key has actually been to make them something called a GUID. So instead of a numeric, 1, 2, 3, 4, and have it incremental, we would actually have a very long alphanumeric, and we would use that and have that increment to make sure that if multiple people or multiple systems are entering in the data, they don't get the same key. It also won't create a choke point or a bottleneck the way incremental might. So if I'm trying to add another book to my database and I know the next entry is 4, as I'm adding my book, if another librarian wanted to add their book and they also thought it was 4 as the next primary key, that would actually run into a problem because then we're going to have both entries that are going to think they are entry 4, but primary keys have to be unique. So by using GUIDs, we would actually be able to bypass that. Foreign keys you may also see as functionally dependent keys. Point to tables with the data. They will always point to a primary key. It's a way to link the data between the tables. You may see foreign keys and primary keys referred to as the same thing or as an ID, but that's not correct. Primary key is not the same thing as a foreign key. Foreign keys are how we are linking data between tables. primary keys are the unique identifier for our record. So, a primary key ensures that we have unique data. Only one primary key is allowed, cannot have null values, and its value cannot be deleted. Foreign keys, however, show relationships between tables. You can have multiple foreign keys, you can have null values, and they can be deleted. For example, let's say we have our table with books, one table with books and then one with the author's name. Normalize the table to make it easier to use. And after we have our table normalized, we are likely to have two tables, one with the books and one with the authors. The way that we could connect them together is we would have a foreign key to the author table primary key. So in the example of my book, book ID is the primary key, author ID and genre ID are the foreign keys. An entity is the thing we are talking about, such as the book. Each entity will have attributes such as authors and titles for each book. Each table needs the data for one entity, such as an author or a genre. This is how we are able to split up the data. For example, if the entity is a book, the attributes might be author, publisher, and title. The reason that this is going to end up being really important is because when we are talking about our databases, we are going to need a way to be able to picture how the data is being saved. Because if we try to just say, show me the whole database, that would actually be really difficult and would likely be very confusing to see that raw data dump. So one of the things that we'll do is an entity relationship table or entity relationship diagram. And that's basically a picture that allows us to see how the data is being saved so that we would be able to see very clearly how the book table relates to the author table. And then if we had other tables, how those would relate as well. It gives us an abstract map, so we'll know the data that we have, the tables that we have, and how they are all linked together so that we can see how our database is organized. Knowing how our database is organized also allows us to make sure that the other people that are using our database are going to follow the same conventions that we've set up. So I hope this made sense. If you have any questions, please let me know, and I hope you're all having a lovely day.